Hello, Math 7 students. We are now doing Module 2, Lesson 16, and it is called Comparing Tape Diagram Solutions to Algebraic Solutions, and we can find that on page 74 in my comp book. So here is page 74 in my comp book, and the title again is Comparing Tape Diagram Solutions to Algebraic Solutions. Our goal for today is we will learn how to use tape diagrams to solve equations. It's pretty fun. I really like it. The question that I want you to be thinking about is, how can the tape diagram help you understand how to solve the equation? Some things that you need to remember are some of these words down here, and I'm going to talk about those. So, things to remember. First thing, an expression is a math sentence built of numbers and symbols and no equal sign. Okay? This right here is an example of an expression. There's no equal sign. This right here is an example of an expression. There is no equal sign. So when you see things like this is called an expression. Okay? An equation, on the other hand, is a math sentence built of numbers, symbols, and an equal sign. So it does have an equal sign if it's an equation. So an example of it is the exact same one from above, except there's an equal sign and the answer. So it says 1/2 of the quantity x plus 8 equals 28. So the equals 28 makes it an equation rather than an expression. 25 minus x equals 15. Notice the difference. The difference is it has an equal sign and an answer, so that makes it an equation rather than an expression. So hopefully that helps you notice the difference between the two. The other thing that you need to remember is a tape diagram. A tape diagram is a model used to see how to solve the equation. So if we have this example right here, 5 times the quantity x plus 2 equals 40. Well, what we can do is we can use our knowledge and our help with tape diagrams to help build this problem so that we can figure it out. So the other thing that I want you to think about, because this is our goal for our lesson, is how do you use tape diagrams to help you with this, is this number right here is called a coefficient. The coefficient tells you how many you have of inside the parentheses. So right now, what this problem is actually telling me is that there are 5 x plus 2's. There are 5 of them. So if we're thinking about tape diagrams, here's our piece of tape. The coefficient that you see tells you how many spaces to divide the tape into. So since this says 5, I need 5 sections in my piece of tape. So here's 1, 2, 3, 4, 5. Okay, so those are my 5 sections of my tape. Inside each section sits what's inside the parentheses. So I need an x plus 2 right here. 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 And I need an x plus 2 right here. So each one of the pieces of tape has to have what's inside the parentheses. Then, where it says equals 40, that's telling you, as the math person, that all of these added together will give you an answer of 40. Okay? So that's how the tape helps you see it. So now what you have to do once you know how to set up your tape is you have to know what to do next. So the first thing that I like to do is count everything that you have, starting with different terms. These two are different terms because in order for them to be alike, they both have to have an x. So there's an x here and a 2 here. So these are not like terms because this is an x and this is a 2. But there are other x's in there. So your first job, the first thing that you're going to do is count the number of variables. And I know you know what variables are. So this is a variable, this is a variable, this is a variable, this is a variable, and this is a variable. So now we just have to count them. How many do we see? 1, 2, 3, 4, 5. Oh, well there's 5 x's. That's how many we have. And then you will notice the operation for each of these says plus, so we're going to put a plus. And now we're going to count the other numbers. They're called constants. So we're going to count these constant numbers right here. They are all by themselves, just numbers. So how many twos do you see? 1, 2, 3, 4, 5. And if you want, you can skip count to write the answer. So 2, 4, 6, 8, 10. So this would be plus 10 because that's how many are sitting in the tapes. Now, what do all of these equal? Well, all of these equal 40. Okay? So now that you know how to do that, you're going to do some logic thinking. Okay? So you have 10 on this side, but you have 40 on this side. What we're trying to do is we're trying to get this 40 to be equal to this side. So right now, I have 40 on this side, and I have 10, but then I also have 5 of something else. So the question is, what number can I multiply by 5 and then add 10 to get 40? Now, some of you are thinking 8, 8, 8. Well, let's try it. If I take 5 times 8 plus 10, does it equal 40? Well, let's try. 5 times 8 is 40. Uh-oh. Plus 10. Uh-oh. That does not equal 40. That actually equals 50, and 50 does not equal 40. So 8 won't work. Okay, so we know 8 is too big. So is there another number that we could try that would work? Well, okay, 8 is too big. If we did 7, 5 times 7 is 35. 35 plus 10 is 45. Too big. Okay, try another one. How about 6? 5. Okay, so let's try that. 5 times 6 plus 10 equals 40. Let's see if it works. 5 times 6 is 30 plus 10 equals 40. I don't know. What is 30 plus 10? It's 40, and 40 equals 40. So you have just figured out that x has to be 6. Okay? Now, some of you are sitting there and going, Mrs. Nelson, I don't want to have to sit here and just try and try and try. And I agree with you. So I'm going to teach you a different way to do it. When you have an equation that looks like this, okay, everybody needs to watch. Everybody needs to see. This equation is telling us that we have to get to 40. So there is this tool called a BU chart. Okay, and what it stands for is build and undo. Okay, the build side tells you as the math person, how did this side get built? The undo side tells you, how do I undo it to get an answer of 40? So I'm going to show you. First thing you ask yourself is, what's the variable? What's the variable? Okay, so the variable in this one is x, so I write x right here. What operation, second question, what operation, math operation, okay, what math operation happened to the x first? So look up here. What operation happened to the x first? Choose the one that's closest to it. What is the math operation that's happening right here? If you said multiplied, you're right. So we're going to put I multiplied by 5. So I had x, then I multiplied by 5, and then lastly, so the third question is, what happened next? So lastly, what happened next? I have 5x. What happened to it last? We added 10. Okay? And then we're at 40, so we stop. So now to undo this, what we have to do is we have to work backwards. So we're starting here and we're going up, and we're going to do the opposite and go backwards. So if we added 10 last, what do we do to take that 10 away? You are correct. We're going to subtract 10 first. If we multiplied by 5 first, then to undo that, we have to divide by 5 second. And when we do that, we'll be left with x. Okay? Now, some of you are going, I am so confused. Let me show you. So there's our build and undo chart. Here is our equation. I'm going to watch you what happens. So the first thing it says to do is subtract 10 off. Now, when you subtract 10 off, you have to keep your balance equal. They have to be equal. So what you do to one side, you have to do to the other. So I'm going to subtract 10 off here. So draw a line and do exactly that. What is 10 minus 10? 0. 0 pair. Yeah, so you make a 0 pair like this, and you write 0 right there. Well, what is 40 minus 10? 30. You're correct. Then what do we have left on this side? We have a plus left, and we have a 5x left. Okay, so what is 5x plus 0? Well, 5x plus 0 is 5x equals 30. So I come up here to my build and undo chart, and I put a check next to subtracting 10 because I just did it. What was the next thing that it said to do? Divide by 5. So I'm going to divide this one by 5. What you do to one side, you have to do to the other. So 5 divided by 5 is 1x, right? Equals 30 divided by 5 is 6. And now you just simplify. What is 1 times x? It is x equals 6. Ah, ta-da! So we just did it mathematically, and we didn't have to guess, okay? So this is how you do it mathematically, okay, which I would prefer. It makes life a lot easier if you actually use the mathematics, okay, called a build and undo chart. All right, so what do we have left in our notes that you need to be working on today? Is I just did that problem with you together, so check it out. It's the exact same thing. Now I have 2 for you to try at home. The first one says 2 sections in the tape of x minus 3 equals 14, and you have 6 sections of the tape filled with 2x plus 1 equals 36. So I want you to try those 2 problems at home, and we'll check them tomorrow when we get into class. All right? So going back to our goal for today, we will learn how to use tape diagrams to solve equations. The question that you need to think about is how can the tape diagram help you understand how to solve the equation? The way that it helps us is that it allows us to see what's going on so we don't get confused. It's really, really handy when you have the distributive property. All right, my darlings, that's it for today's lesson, and I'll see you all tomorrow. Bye.